Okay. Hello, everybody. This is Mr. Combs, and we're going to look at numerical summaries of data. So basically, we have numerical summaries of data, and on Monday, we'll look at the normal distribution, and that will be the last of our new material. So then the rest of the time, so next week is our last week of class, so we'll meet on Monday. We will not meet on Wednesday. I will leave Wednesday for you to work on finishing up everything. There is a test 4 for you to take online. There's a final exam for you to take online, and the final exam is password protected. So I will send either Mr. Wright or Miss Creech the password. So whenever you're ready to take it, just get the password from either one of them. Today, Wednesday, and Monday will be the last 2 times that we have new material. The rest of the time, I'll be available if you have questions, but you just finish up the work, and I'll try to send all your tests back to you in the mail and everything. You'll know your score on exam 4 once you take it, and you'll know your score on exam the final exam, sorry, once you take it too, because they'll be taken online. So let's talk about numerical summaries of data. We talked last time about visual summaries of data, and we talked about the histogram and the stem and leaf plot. Well, actually, we talked about the stem and leaf plot first, then the histogram. And so that's one way of summarizing data, so you can sort of make predictions about it. And we looked at the histogram, and we saw maybe that based on the way it looked, some data values, or most of the data values were low, or most of the data values were high, or the data values were all the same across across all of the different classes. But we could also summarize data using statistics, or basically numbers that give us some information. So let's look at this situation, and I'm creating a video. No one's on with me now. If somebody comes on, I may say hello, but I'll just continue on. It says, let's say I wanted to study the number of credit hours a student at HCTC takes each semester. It would be very difficult for me to ask every single one of HCTC's approximately 3,000 students how many credit hours they're enrolled in this semester. So I would choose only a sample of students to survey. I decide to ask the students in my Tuesday-Thursday afternoon class the number of credit hours they are taking this semester, and I collected the following results. Now, I have a question here. Before we go any further, why is this class not a really good sample of all students at HCTC? Well, first of all, it's not big enough. The sample size is not big enough. Remember, we said earlier that at least 30 is a good sample size, 30 or more. This is only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So this is only 25, so I'm really 5 short of having an acceptable sample size. These are students in one class that meets Tuesday, Thursday afternoon. Since all students at HCTC do not take classes only on Tuesday, Thursday afternoon, I would need to, from my sample, pull students who are totally online, students who are dual credit. None of the students in my class are dual credit students in the other class that I ask. That's a college algebra class, and they're all here at the college. None of those students are dual credit students. So you all basically are not represented in my survey, but you're students at HCTC, and you're taking credit hours, right? There are, so in order to have a good sample, I need 30 or more. I need to have students from Tuesday, Thursday classes, Monday, Wednesday classes. I need to have dual credit students. I need to have college students, both traditional and non-traditional students. I need to have students from morning classes, from evening classes, from night classes. I need to have students, like I said, who are completely online, students who have no online classes, students who have a mixture. So the students in my class, it's not a very good representation of students at HCTC. So, if I were really trying to do a study, I probably would use a larger sample than this. But this is what we have, and this is what we're going to work with, okay? So even though we know this is not a good sample, it is what we have, like I said. Let's take a closer look at the data. First of all, I'm looking at data, and I notice that most of these are 12, 15, 13, and around that, around that number. I do have a few numbers that are very different from that, though. I have a 6, if you'll notice. I have a 7, and I have a 20. So someone in my class is only taking 6 credit hours. Someone is taking 7, and I said, well, how do you manage to take that? And they have a 3 credit hour class and a 4 credit hour class. And then someone is taking 20 hours, and I'm thinking, well, how do you manage that? That's a lot. In fact, I think if you take 21 or more, you have to have special permission from the vice president, I think, or maybe an academic dean, because that's a lot of credit hours. But anyway, those are not the typical values, so those are what we call outliers. They're very different from the other values. I just got a text, I'm sorry. So they're very different from the other values, so we call those outliers. And outliers can affect summaries of the data, but there's often nothing we can do about them. We just have to acknowledge them and move on. So the outliers will affect the data, and we'll look at how that may happen later on. Some people actually look at outliers and throw them out, but if you do that when you're doing a statistical study, you have to make sure that it's very clear to the person reading your study that you had some outliers and you just took them out of the data. Now you can do that, but you have to justify it as well. So make it very clear that you did that and then justify it. I happen to know that the person who's taking 6 hours, for example, is a visiting student. They're auditing the class, so they're just actually sitting in the class. They're not required to turn in any of the work in the 2 classes that they're auditing. That really is not the typical student. That's a special case, so I might throw 6 out as not representative. But I would have to explain that in my study. What conclusions can we draw from this data? Well, there are 3 groups of measures that we use to help us draw conclusions. The first group of measures we'll call measures of central tendency. So measures of central tendency, these are ways of describing the middle or typical value of the data. So when you talk about the measures of central tendency, you're talking about what is the average data, or what is the middle term. All right. Now, if we, you remember when we said that we had a bell-shaped, a histogram could have a bell-shaped curve, and we said that that the values were centered around or clustered around a certain value in the middle, well, that value would be one of these measures of central tendency, the mean, median, or the mode. We also have a mid-range is another one, but the three that are most common and most important are the mean, median, and the mode. And so let's talk about the mean. So the mean is the average, and I'm sure you've found the average of something before. This is used most often. It is found by finding the sum of the data values and dividing by the number of data values you have. The symbol for the mean of a sample is x bar, and it's just x with a little bar over it, and it's not really, I mean, my little graphic is messed up there. I'm going to see if I can fix it, but that's usually what we say, x bar. And the symbol for the population mean is a Greek letter, mu. Now we're going to be talking about, we're going to be talking about samples mostly. So we're going to be looking at the sample mean. The median is the value that is in the exact middle of the data when the values are arranged in numerical order. So it's another way of describing the middle. For an odd group of numbers, you can find the median by arranging the numbers in numerical order and picking the middle number. For an even group of numbers, you can find the mean or average of the middle two numbers. So if you have an odd group of numbers, then there is a middle number. If you have an even group, there's not a middle number, but what you do is you find the average of the two middle numbers, and that will give you the median. Okay? And the mode is just basically the value occurring most often in the data set. So these are ways to represent the typical value. The mode is often used when looking at categorical data. So if you have like brown eyes, blue eyes, green eyes, what is the typical eye color? You can't really add all those eye colors together and divide by the number of eye colors you have to find the mean eye color. So we talk about the mode when we're dealing with categorical data. And then lastly, we have the mid-range. The mid-range is the number exactly midway between the highest and lowest value. The mid-range is found by finding the average of the highest and lowest data value. So you just add the highest number and the lowest number together, and you divide by 2. Now, the mean, well, basically the median and the mode should be one of your data values, right? The mean, well, maybe the median might not if you have to, for an even group of numbers. But the mid-range and the mean could be, it'll be the middle, but it could be, you could have a mean or a mid-range or even a median that is not actually one of your data values, right? But it still describes the middle of the data set. All right. We also want to measure how spread out the data is. So we could basically have a situation where I have maybe a average of so for example, if I've given a test, I might have an average of 60 on the test. Well, that tells me a little bit. That tells me that the typical value was a 60, but I could learn much more by looking at what we call measures of dispersion. So do I have a 60 because most people got around 60, or do I have a 60 because a lot of people got a very low score and a few people got a very high score? So how is the data spread out? So the range is the difference in the largest value and the smallest value. If the range is large, it means there is a big difference in the largest and smallest value, right? Our largest and smallest value, the largest was 20, the smallest was 6. So there's 14 points, I guess, in between the largest and smallest number. So that could mean the data is spread out. But now remember, 6 we identified as an outlier, so really that may not be a good, the range may indicate, a range of 14 indicates that the data values are really spread out. There's a large difference between the first and the last number, or the smallest and the highest number. But remember that we only had 1 6, so the range is affected by an outlier. The data really isn't as spread out as that. Then we also have something called the standard deviation. And the standard deviation is a measure of how much we might expect a data value to differ from the mean. The standard deviation, basically, if you pick a data value from the data set, the standard deviation is an estimate of how much that differs from the mean. So in fact, we usually say a value is a certain number of standard deviations from the mean. The standard deviation of a sample is represented by the symbol S, and the population standard deviation is represented by the symbol sigma. The standard deviation is always positive. You can think about it as a standard deviation, a certain number of standard deviations above the mean and below the mean. But the standard deviation is always positive. The standard deviation will be 0 if all the data values are equal. So if the data values are equal, so if you have 12, 12, 12, 12, 12, 12, 12, the standard deviation will be 0 because there's no difference in a data value and the mean. As the data gets more spread out, the standard deviation will become larger. And there is a complicated formula for finding the standard deviation, but more on that later. Finally, we may want to measure the position a certain data value possesses in relation to the rest of the data. Now, any of you who have taken the ACT, you are very familiar with this kind of ranking, because you're given, when you get your ACT results, you're given how you scored based on percentiles. And basically, if you're in a certain percentile, that means that, like let's say you're in the 50th percentile, that means that most of the people scored at or below, that means that you scored, I'm sorry, now what I mean is, sorry, I got distracted for a minute. If you score in the 50th percentile, what that means is that 50% of the people taking the test scored your score or below your score. If you score in the 75th percentile, that means 75% of the people who took the test scored your score or below your score, right? If you score in the 90th percentile, then that means 90% of the people who took the test scored at your score or below. So percentiles are basically based on 100. So there are 100 of those. But to make working with this kind of thing a little bit simpler, we talk about quartiles. And quartiles basically are values that divide the data into quarters, into 4 parts. Right? So the first quartile, or Q1, is the value so that 25% of the data values are below it. So if you score in the first quartile, if the ACT was results were given to you in quartiles, which they might be now, I don't know, but when I took the ACT, I was given a certain percentile that I scored at. Then that means 25% of the people scored your score or below. In the third quartile, that means 75% of the data values are below it. And the second quartile is 50% of the data values. And that's the same. The second quartile is the same as the median, since the median is the value so that 50% of the data is below it and 50% is above it. Now, if you notice, we talked about percentiles. I didn't write anything about percentiles, but the first quartile is really the 25th percentile. The second quartile is really the 50th percentile, and the third quartile is really the 75th percentile. So like we said, quartiles divide the data into quarters. 25% of the data is between the minimum value and Q1. 25% is between Q1 and the median, and 25% is between Q3. I'm sorry, 25% is between the median and Q3, and 25% is between Q3 and the maximum. So the quartiles divide your data into 4 distinct parts. When the minimum value, the Q1, the median, Q2, and the maximum value are considered together, we often call that the 5-number summary. And then we have something called the interquartile range. It's the range of the middle 50% of the values in the data set, and you get it by subtracting Q3 minus Q1. So some of these measures can easily be found by hand, but others have complicated formulas. Since we have technology available, why don't we just allow technology to calculate these measures for us? We'll use an Excel file to find these statistics. Remember, we are dealing with the sample. We're dealing with samples here, so any values or summaries of the data that I find, I'm going to call statistics rather than parameters. And so this Excel file can be found in the myopenmath.com site. So what I'm going to do is I'm going to stop sharing my document. We're going to come back to the document in a minute. And I'm going to start sharing my screen if I can. I hope I can. And I'll show you where that file is. Okay. So now let me go to myopenmath, and hopefully you can see myopenmath here, and if you look at myopenmath, you'll notice that I have a new bar here, a new block. It's statistics Excel file. If you click on that, it says copy of basic statistics. When you click on that and open it, you get the file. Now what I've done is I've already put in the data for our data for credit hours, and this basically gives you everything you need. Now there are a lot of stuff you don't need, like for example, we're not talking about the variance. We talked about skewness, but we are not talking about having a certain number for skewness. It gives you population parameters, but we only need the sample statistics. This tells you about the percentiles. We probably won't need that. This tells you about the quartiles. We will need that. So we don't need everything in this chart, but this chart has most of what we need. The only thing this will not tell you is the mid-range, but the mid-range can be easily found. All right? So what you're going to do to use this whenever you have homework problems is you're just going to delete all of the numbers in data entry and then fill your own numbers in. I think you can fill in up to, well, I don't know, there's a lot. So you won't have to fill in very many at all. So, and once you start putting numbers in here, once you get them all entered, then the information will pop up here. So I've written this stuff down. So let's go back to the document and actually calculate some of these things. Or back to the Blackboard Collaborate session. Let me see here. I've lost it. Oh, here I am. Here I am. So I'm going to get rid of that. I'm going to pull back up the numerical summaries of data sheet. So what I want us to do is I want us to find the mean, median, mode, mid-range, range, and standard deviation, 5-number summary, and interquartile range for our data. And basically what I did was I put the data values into that Excel file, and here is what I came up with. As you can see, or as you could see from the Excel file when I had it up, X bar, or the mean, was 12.56. The median is 12, and the mode is also 12. Now notice how the mean, median, and mode are basically the same number. The mean is a little higher than the median and the mode, but they're around the same number. This is important, and this tells us, or this gives us a clue that our numbers are distributed normally, and we'll talk next time about what that means for, to have a set of data values that are normally distributed. So we'll look at that. All right, what else are we looking for? The mid-range. So now the mid-range is not given to me in the document, but I can easily find it because it's just basically the average of the highest and lowest number. So the lowest number is 6, the highest number is 20. Again, excuse my crazy writing with this mouse, and I'm going to divide by 2. So that's going to give me 26 divided by 2. And that gives me 13. So the mid-range is 13. So notice that the mid-range is it's the data value exactly in the middle. It's very similar to the mean, right? If I rounded up the mean, I would get 13. So it's in keeping with the mean, median, and mode. The reason why this probably is not 12 or you know, to relate better to the mean, median, and mode is because that 6, remember, is an outlier. And I typed, or I wrote mid-rang instead of mid-range. There we go. All right, the actual range then is just the difference in the highest and lowest. So that's 20 minus 6. And that's 14, so that might suggest that the data is very spread out, but we happen to know that the data is not. Most of the data values are 12, 13, 15. So we could just say that we're going to chalk that up to having an outlier. Both the highest and lowest value are outliers, so that affects that range. And then I don't know if you noticed the standard deviation S when we had the chart, or when we had the Excel file up, but it was actually 0.58. So that means that if a value is 1 standard deviation above the mean, we can expect that value to be, if the mean is 12.5 or 13, we can expect a value 1 standard deviation above the mean to be 16 something, right? Or 16, because if I say 12.5 is 13 and 2.5 is 3, 13 and 3 is 16. We can expect a value that is 1 standard deviation below the mean to be around 10. All right. Now let's look at the 5-number summary. So the 5-number summary starts out with the minimum value, and that is 6. Then I have Q1, and I got Q1, or the first quartile, and that's 12, and I got that right from the Excel file. So what that means is that 25% of the data is 12 or below. 25% of the data is below 12. And the median is 12, as we saw before. Q3 is 13. Now remember that between Q1 and Q3 is 50% of the data. So 50% of our data is between 12 and 13. So this gives us a clue that our data is really not as spread out as the range would suggest. So you can't always go by the range for a measure of spread. Remember that if you're only 1 standard deviation from the mean, you're only about 3 numbers off, right? So Q3 is 13, and then the maximum is 20. And then the interquartile range is basically the Q3 minus Q1, and it's also given to us in the Excel file. So IQR is 1. So that tells us that even though there are 14 points in between the highest and lowest value, there's only 1 point in between the highest and lowest value of 50% of the data. All right, well, that's what I have for you. You have a homework assignment, and remember to check out the course outline. We're going to finish up a little bit early today, and I'll get this video posted as soon as possible. And I'll see you on Monday. Remember, Monday will be the last time that we meet. The rest of the time will just be catch up and getting all of our stuff done. I'll try to get your test out to you, and I'll let you know grades as soon as I get everything graded and calculate those. All right, well, I will see you later, and have a good day and good rest of the week.